Good morning, everybody. In this session, we are discussing on depreciation, which is comes under project engineering. First of all, we should know about what is depreciation. This is a measure of the decrease in value of any substance, and there is different reason behind that, like physical deterioration, technological advances, economic changes, or other factors which ultimately will cause retirement of the property. That means we can say in this way that the value of any substance is decreased in different reasons. Now, based on different reasons, we classify here two types of depreciation: physical depreciation and the functional depreciation. The physical depreciation actually depend upon the accident, wear, tear, corrosion, and any deterioration, etc. And the functional depreciation, that is technological advances, change in demand, shift population center, changes in requirement of public authority, inadequacy or insufficient capacity for the service required, abandonment of the enterprise. Now, if we follow these two different types, we can very easily say that the physical depreciation estimation is much more easier than the functional depreciation. Now, to discuss in detail about the depreciation, we should know some factors first. That is a depletion, maintenance, repair, service life, salvage value, scrap value, present value, book value, unamortized cost, market value, replacement value. We go for step by step. First one is the depletion. Capacity loss due to materials actually consumed is measured as depletion. This type of depreciation is particularly applicable to natural resources. Example, timber, mineral, oil deposits, etc. So the depletion cost is what? Initial cost into amount of material used by original amount of material purchased. So we can say in a word that this depletion is also a depreciation, but it's depend or is actually regarding the natural resources. Then you go for the maintenance. It means the idea of constantly keeping a property in good condition. Means if we want to maintain a property in a good condition, we should invest some money for that. That known as a maintenance cost. Then go for the repair. It means replacing or broken or own part of a property. If some broken parts are there, if some repairing is required, the money we required for that known as a repairing cost. Then you go for the service life. The period during which the use of property is economically feasible. Now I put some stress on this particular term, economically feasible. So for example, suppose we buy a refrigerator a few years back. After a few years, maybe suppose 10, 15 years, we are facing that very frequently we are going to replace some parts of the refrigerator. There is also a very huge amount of cost for that. Moreover, the energy consumption for this refrigerator is much larger than the previous time. That means what? We are using the refrigerator, but it's not economically feasible. Okay, so that is a condition where we can restrict the use of the refrigerator. Fine. There is a period during which we can use the property in a economically feasible manner. Then go for the salvage value. It is the net amount of money obtainable from the sale of a used property over and above any charges involved in removal and sale. Means what? We are having a property, is still doing its job, but I am going to sell that one, and the money I receive from that one as a salvage value. Just go for an example. Suppose I have a mobile phone and I bought that thing 2 years back. And now I want to sell that one. And the money I'm getting from that particular mobile phone is a salvage value. Because what? Because the mobile phone is still doing its job as a mobile and it's still economically feasible. But I have another option to buy another one, so I am selling that one. Fine. Now this salvage value actually depends upon some factor. That is the location of the property, existing price level, market supply and demand, and difficulty of separating different parts. These all factors actually affect a lot on the salvage value determination. Then go for the scrap value. If the property cannot be disposed of as a useful unit, it can often be disassembled and sold as junk to be used again as a manufacturing raw material. The profit obtainable from this type of disposable is known as a scrap or junk value. Means what? We are having a component which is not at all in a usable condition right now, and I want to just separate different parts and wait as a junk raw material and sell that one. The value I'm getting from that one as a scrap value or junk value. Now, what is the present value? It may be defined as the value of the asset in its condition at the time of valuation. So, when I put the thing in the open market, I'm getting a value, it is a present value. Then I go for the book value or unamortized cost. The difference between the original cost of property and all the depreciation charges made to date. What is that actually? Go for example. Suppose we have a component, initially its cost is 100 rupees. And I consider that the lifespan is suppose 10 years. And I also consider that first year 10 rupees decrease, second year another 10 rupees decrease. That means throughout the second year 20 rupees is decrease. So if somebody asks you that at the end of second year, what is the book value or unamortized cost, the value will be how much? Original cost, that is 100 minus this 2 into 10, that is 20. That means 100 minus 20, that is equal to 80. Clear? Then go for the market value. The price which could be obtained for an asset if it were placed on sale in the open market. Just say that this present value, book value or unamortized cost and the market value all are representing the same value but in a different way. Then go for the replacement value. It is the cost necessary to replace an existing property at any given time with one at least equally capable of rendering the same service. Means we are having a particular substance which is not at all doing its job. I want to replace this particular one by a new one, and the money required for that one is a replacement value. Now the different factors we know, different reasons we know. But the thing is that we have to find out the depreciable amount. So regarding that, there are two different ways. One way is not considering the interest. Another way is considering the interest. So in first case, where we are not considering the interest, the methods are straight line method, decline balance, and some of the year digit method. And for considering the interest, there are sinking fund method and the present worth method. First, we go for the straight line method. What is that actually? This straight line method, I consider that depreciable amount is a particular amount which is reduced. That value is same throughout the whole service life. Either we can say in this way, if my service life is suppose n, okay, n is equal to 10 years, and I consider that every year the value d is reduced. The d is same. Okay, and v is here what? The original value of the property at the initial time, and v is the salvage value. So if I know v and vs, if I know n, I can find out d. The d is what? The amount depreciable every year uniformly. Okay, but the question is that after this reduction, what is the asset value? Suppose a is any year within this nth year, or maybe equal to the n, maybe equal to the service life. That means we have to know about the v, the original value. We have to know about the eighth year, maybe 0, 1, 2, 3 up to the nth year, and d is a depreciable amount. So v minus a into d give you the asset value va. That is the two working formula for this straight line method. This d for the depreciable charge and va is for the asset value. Then I go for the declining balance method. That is used for annual depreciation cost as a fixed percentage of the property value at the beginning of the particular year. Okay. Now initial cost of the substance, suppose v, and fixed percentage factor is f. So how this method actually working? At the end of the first year, the asset value is how much? Va equal to v into 1 minus f to the power 1. What does it mean? It means that initially we have started with the original value. If the factor is f, then at the end of first year, the asset value will be va. That means what? At the beginning of second year, that is va is our new asset value. In similar fashion, at the end of second year, again this one, where the power will be replaced 1 by 2. At the end of 8th year, this 2 will replace by a. At the end of nth year, that a will replace by n. Fine. Now look here that va equal to v 1 minus f to the power n. I can put here va equal to vs as because a is replaced by n, salvage value. Now this equation we can modify and get a terms like that, which actually gives us this factor f. Okay, the fixed percentage factor. And that is the working formula for this decline balance method, also known as Matheson formula or textbook method. Okay. Now go for the combination method. Now why this thing actually arrives? Because we find that the straight line method and decline balance method have some advantages and have some limitation also. First go for their advantage. In straight line method, if we having this formula, so we can see that we can very easily put here b is equal to 0. That means salvage value equal to 0. What does it mean actually? It means we can completely utilize the service line. Okay. But as because in straight line method, the value d is same throughout the whole service life. So that means we cannot consider any advantage over that. Whereas in the case of decline balance method, because of this if percentage factor, and that is depending upon the asset value at the beginning of every year, and this asset value is decreasing throughout every year. So as a result, the due to this percentage factor in the decline balance method, in the early life, there is a huge amount of reduction in depreciable value than the later life. Okay, and due to that, we can take advantage of tax. Whereas we cannot put in this particular textbook method or decline balance method this v is equal to 0. That means we cannot put v is equal to 0 means we cannot consider complete service life of any substance. So by using these two methods, we can go for combination method. And how we can take both the advantages? In the first step, we go for the decline balance method, and in the second step, we go for the straight line method, so that we can get both the advantages. Then we go for the sum of the years digit method. The annual depreciation cost is equal to the yearly depreciation factor into the total depreciable value at the start of the service life. Now look here, the total depreciable value at the start of the service life, how we can find out that one? V equal to 20,000, V is equal to 2000. That means throughout this n equal to 5 number of service life years, the total depreciable amount is 20,000 minus 2,000 equal to 18,000. That is clear to everybody? Now, for this yearly depreciation factor, the number of useful service life years remaining by the sum of the arithmetic series of number from 1 to n. Clear? Now, this arithmetic series, what is that? It is 5 plus 4 plus 3 plus 2 plus 1, that is equal to 50. Now look, that is again fixed for every cases. So, the only thing change is that the number of useful service life years remaining. As because the depreciable amount is assumed at the beginning of every year, so that means that this depreciation cost for the first year is how much? At the beginning of first year, we have to assume. In that case, the number of useful service life years remaining how much? If we have n equal to 5, 5. That means 5. That means 18,000 into 5 by 15, that is equal to 6,000. Now this 6,000 is the depreciable cost for the first year. Okay, but after this depreciation, what is the asset value at the end of the first year? That is 20,000 minus 6,000, that is equal to 14,000. That means our journey starts with 20,000 initially at the beginning of first year, but at the beginning of second year, our V is now 14,000. Okay, now go for the second step. The depreciation cost for the second year is how much? 18,000 into the number of years remaining how much for the beginning of second year? 4 year, 4 by 15, that is equal to 4,800. So the asset value will be how much? 14,000 minus 4,800, that is equal to 9,200. Now, where our journey starts with V equal to 20,000 at the beginning of 0th year, now at the end of second year, the value of V is equal to 9,200. Okay. Similarly, if we go for the third year, fourth year, fifth year, we're having this depreciable amount and respectively the asset values. Now look the charm. If we completely find out the asset value up to this end of the service life, this particular value must be equal to the salvage value of the given problem. If it is math, that means your solution is okay. Then you go for the another method known as a sinking fund method, but that method is actually considering the interest. Now how are we finding the value here? That is equal to the sum of all the deposits plus acquired interest at the end of the service life. And regarding that, we are using here the equation of ordinary annuity, that is capital R. That is equal to V minus Vs, I by 1 plus I to the power n minus 1. The total amount of depreciation factor after 8th year, how much? V minus Va. Now just put here V minus Va and rearrange the equation. What we have? R into 1 plus I to the power A minus 1 by I. Just having that one here. Clear? Now I just put here in the next step V minus Va, and in place of R I am putting here this whole term. If I put here, I will see that this I and small I will cancel out and we are having this particular formula. And then again rearrange for the asset value further, we are having this particular formula. That is the working formula for sinking fund method, where we are considering the interest. And if we are going to discuss in detail, so what we can say that V we know, original value, Vs we know, salvage value, small a we know that any year within the service life, and n is a service life, and this small I is a interest rate per year. Now this is a graphical representations of different methods, or rather we can say we can compare their trend of different methods. So this is a graph where this axis showing you the service life in years and that axis showing you the book value. Okay. Now look here, the sinking fund method is actually making a the straight line method actually giving you the straight line. Okay, decreasing uniformly. Okay, and go for the textbook decline balance method. We can see that in the early life, the asset value is decreasing in a higher rate compared to the later life. Okay. And in the sinking fund method, as we are discussing, we are considering about the interest, the nature of the curve is like this. Okay. So this is the charm of these different methods based on their different formulations. Then we go for the present worth. It is again a method for finding the depreciation value, but in a different way, which considering the interest. The present principal of which must be deposited at a given interest rate to yield the desired amount at some future date is known as the present worth. According to the compound interest, that is a formula we all know. That is the sum assured value. P is the present principal amount. I is the interest rate per year, and N is the service life in years. We just rearrange the equation. P equal to S by that one. Okay. That is the equation for finding out the present worth value by compound interest rate. What does it mean? It means that if I want to acquire S amount of value after n number of years, we having a I amount of interest rate, we require P amount of principal by compound interest rate. Clear? Similarly, for continuous interest, we require this particular formula where R is a nominal interest rate to get the P amount of principal from S amount of to get the S amount of sum assured value. Now we're going to discuss about some numerical problems based on different methods one by one. The first problem, a piece of equipment originally costing 40,000 rupees was put into use 12 years ago. At the time the equipment was put into use, the service life was estimated to be 20 years and the salvage value and the scrap value at the end of the service life were assumed to be 0. On this basis, a straight line depreciation fund was set up. The equipment can now be sold for 10,000 rupees and a more advanced model can be installed for 55,000 rupees. Assuming the depreciation fund is available for use, how much new capital must be supplied to make the purchase? There is a problem statement. Now go for the solution. First see here the straight line method is declared here. So we have to find out the straight line method depreciable value. That is D. Now V we know 40,000 given and the salvage value given here 0. So V is equal to 0 and the service life is equal, given here 20 years. So V minus Vs by N equal to 2,000 rupees per year. Then you just see here is put into use 12 years ago. What does it mean? That means now we are at 12 years. Okay, after 12 years. That means we have to find out that throughout the 12 year, the depreciable amount is how much. So A into D, that is your D, 2000, that is your A. So that gives you 24,000. Now you want to buy a new one and you have a value that is 10,000 at your hand by sold the old one. But another term is given here, that is assuming the depreciation fund is available for use. That means what? The value reduced throughout these 12 years is actually, we have to consider that value is at our hand right now at the end of 12 year. That means at the end of 12 year, we are having both the value, that's 24,000 plus this 10,000, that is equal to 34,000. Clear? So the new capital required here, that is 55,000 minus 34,000, that is equal to 21,000. Next problem. Initial value of a property is 75,000 and at the starting useful service life was estimated as 10 years. If the salvage value at the end of the service life is 10,000, then what is the asset value after 4 years from the beginning considering decline values method? So this method name given here. So initial value is V, 75,000, V is equal to 10,000, service life 10 years. So first we have to find out the factor, that is F. If by this formula we are having this value, this one. Now the asset value, that is the VA, V4, V4 equal to what? V into 1 minus a to the power 4. Putting all the values over here, we are having the value. That is your asset value after 4 years by this decline balance method. Then you go for the next problem. An equipment has an initial value 1 lakh with 8 years service life and 0 salvage value. Find out the annual depreciation cost for first year using sum of year digit method and the asset value after first year. That means you have to follow here the sum of the year digit method. So first finding out the what V, Vs and N is given and finding out the arithmetic series of the number of years service life, that is equal to 36. Then find out total depreciable value, that means V minus Vs, that is 1 lakh again. Okay. Then the yearly depreciation factor first year is how much? That is the number of service life year remaining by the arithmetic series 8 by 36. So the annual depreciation cost for the first year is how much? Total depreciable value into this factor, this one. So we are having that one. That means the asset value after first year is how much? This 1 lakh minus this depreciable amount throughout the first year, that is equal to your asset value at the end of first year. Okay. Next problem. The original cost of a property is 30,000 and it is depreciated by a 6% sinking fund method. Okay. What is the annual depreciation charge if the book value of the property after 10 years is the same as if it had been depreciated at 2,500 per year by straight line method? There is a combination of both the method. Okay. Charm of the problem. So initial value is 30,000, salvage value is 0. We don't know. And it is a 10 years. First, we have to find out the VS by using the straight line method. It's given in the problem statement. So you put here that that D value is given here 2,500 per year. P is given, N is given, VS is unknown. We finding out VS. That VS actually have to put in the sinking fund method VS. And based on that, finding out the R value by putting here the I is equal to 0.06. Okay. And A is equal to 10 years. We are having this particular formula V minus Vs into I by 1 by 5 to the power n minus 1 and having this formula of R. So we are having this value and this is your depreciable charge using the sinking fund method. Next problem. A bond has a maturity value of 10,000 and is paying discrete compound interest at an effective annual rate of 3%. Determine the present worth at a time 4 years before the bond reaches maturity value. Fine. So here the sum assured value is how much? 10,000. Interest rate is how much? 3%. It is 0.03. And service life is given here 4 years. So present worth after 4 years by compound interest rate is how much? P equal to S by that particular one. Put all the values over here. We are having this P value. Okay. So by this 5 problem, I am just going to discuss about the 5 different methods of finding the depreciable value or depreciation value. And there are some more problems that you can practice at your home. You can make a screenshot of that different problems for your practice. And that's all for today. And in our next session, we are going to discuss in detail about the interest. Thank you.